Hello friends, welcome to the course Foundations of R Software. Now you can recall that in the last two lectures we had discussed different types of mathematical operations in the R software, and we had considered the mathematical operations when we are trying to consider scalars, data vectors and a combination of them. And we had essentially learned that how to do addition, subtraction, multiplication and division with the data vectors and scalars. So now in this lecture we are going to move forward and we are going to consider some more operations. So as we have done in the last two lectures, similar type of thing we are going to do in this lecture also, and we are going to understand how R does the power operation, modulo division, integer division. Well, these things are important, and you know that when you are trying to do the mathematical computation, these things are required in many situations. So this is what we are going to do. We are exactly going to follow the same pattern what we have done in the last two lectures, and we will try to understand that how R performs these operations in the software. So we start our lecture. Now you can see here that in case if you want to compute the expression like 2 cube, means you are trying to multiply 2 3 times, then how are you going to do it? So in the R software there are two notations to indicate such power operation. One here is hat. Hat, you can see this is one of the key on your keyboard, and second option is 2 stars. You can recall that when you are trying to use only 1 star, this is indicating the multiplication, and when you are trying to indicate 2 stars, this is going to indicate the power operation. So now suppose if you want to compute 2 cube, so in R you have to write it like 2 hat 3, or other alternative is you can write down here 2 star star 3 like this. Now you can see here, this is what example I have taken here. I want to compute here 2 cube, and I have written this here as a 2 hat 3, and which is giving you an answer 8, and the same thing I have written as 2 double star 3, which is giving you an answer here 8, and this is here the screenshot. So you can see this is how you can do the power operation when you are trying to consider a scalar. Similarly, in case if you want to find out the square root of something, say 2. So you know this square root of 2 can be written as 2 raised to the power of 1 upon 2 or 2 raised to the power of here 0.5. So now after this you can very easily write this quantity in R as 2 hat 0.5 or 2 double star 0.5, and this is what I have shown you here, that if you try to see, this is the value of square root of 2, and this is giving you 1.414214, and similarly the same operation you can do with the double star also. This is also giving you the same value. And similarly if you want to find out 1 upon square root of 2, then this can be written as 2 raised to the power of minus 1 upon 2, which is 2 raised to the power minus 0.5, and then you can write down here this thing here as a 2 hat minus 0.5 or 2 double star minus 0.5. Yeah, don't get confused that this minus is going to be operated first, because you are going to follow the rule of BODMAS, right? So in case if you want to compute 1 upon square root of 2, then you can write it like this, 2 hat minus 0.5, and this will give you the value 0.7071068, and this is here the screenshot of the same operation. I hope it is not difficult and it is very easy for you to understand after understanding the earlier lectures. So now these operations are related to when you are trying to do the power operation with respect to a scalar, right? Now I try to do the power operation when one of the value is a data vector and the power is a scalar. You know that, for example, when you write 2 cubes, and then this is one value, this is another value. Suppose I call it, say here value 1 and this here as a value 2. Now you have different combination. Value 1, value 2, both are scalars. Value 1 is a data vector and value 2 is a scalar, or third option can be both value 1 and value 2 are data vectors. So we will try to see all sorts of combination, and you try to understand how R function. So now I try to take it here, this data vector, say 2, 3, 5, 7, and then it has here a power 2. So now in case if you try to operate it, the same rule operates here what happened in the mathematical operation, that this hat 2 is going to be operated over all the elements. So this will become like 2 square, 3 square, 5 square and 7 square, and this will give you the value here 4, 9, 25 and 49. This is as simple as that. As you have done with addition, subtraction, multiplication, division, just like that, power operator will also be entering inside the data vector, and it will make the operation on each and every element in the data vector. So you can see here, this is the screenshot of the same thing. Now after this, I try to take a similar example. So I try to take here two data vectors. Let us call it here, say data vector 1 and another data vector here, say dv2. So first data vector, this has got the number of elements which is 4, and the second data vector has number of elements 2. So the number of elements in the second data vector is the multiple of the number of elements in the first data vector. So what will happen here, that if you try to recall the earlier operations, this will be your here position, say here 1, 2, 3 and here 4. So in the dv1 you have 4 values here, 2, 3, 5 and 7, and say dv2 you have here 2 values, 2 and 3. So first of all, the operation will be like as here hat, and so first this block is going to be operated, and you will get here 2 hat 2 and 3 hat 3, which is here 4 and here 27, 2 square and 3 cube. Now after this, when R moves further, it does not find any value over here. So what it does, it will copy this value here 2 and 3, and then the values at the third and fourth positions will be operated with these two values, and you will get here 5 square and say here 7 cube, and this will give you here the value 25 and 340. So you can see it was working in the multiplication, division, addition, subtraction. The same way power operation is also being done in this case. And now in case if you try to take here one more example, where once again I am trying to increase the number of data values in the two data vectors, but I am trying to keep them as a multiple. You can see here now this 1, 2, 3, 4, 5, 6, there are 6 values, and in the second data vector there are 2, 3, 4. So now you will see here this 2, 3, 4 will come over here, and it will be like this here 2, 3 and here 4, and then once here this 2, 3, 4 will come here, and it will become here 2, 3 and here 4 like this, right? And then you will get here the value here 1 square, which is here, 2 cube, which is here, 3 to the power of 4, which is here, 4 square, which is here, 5 cube, which is here, and 6 to the power of here 4, which is here. And if you try to get this value in the R software, they will come like this, no issues. And this is the screenshot of the same operation. Okay, now I try to take one more example where I am trying to keep the length of the second data vector, which is not the exact multiple of the length of the first data vector. So this is my here dv1, which has here 4 values, and this is my here dv2, which has only 3 values. So the same thing will happen here also. If I try to write down here dv1 and dv2 values, so dv1 is here 2, 3, 5, 7, and dv2 here is 2, 3, 4, and then its positions are here like as here 1, 2, 3 and here 4. So now what will happen with this power operation, that this block will be operated first, and you will get here the values 2 square, 3 cube, 5 is power of here 4, and after that R will get confused that there is no value here. So what it will do, it will try to copy the same block here. So the same value will come here 2, 3 and here 4. So R will try to operate here with the first combination 7 and 2, and it will make it here 7 square. But after that, what to do with 3 and 4? There are no values in the data vector 1 which R is getting to operate with the value 3 and 4 here. So it will stop here, but it will give you here a warning that the longer object length is not a multiple of the shorter object length in this vector. And this is here the screenshot. So you can see here it is not a very difficult thing. I mean, that is exactly in the same way the other operations were happening. So before I move further, I try to give you this illustration in the R software. So you can see here, if you want to make it, want to find out here 3 square, that is 3 hat 2, and the same thing if you try to make it here with the 2 star symbol, it will become here 3 double star 2, it is again 9. Now in case if you want to find out the square root of 3, you can express it like this, 3 hat minus 2, this is 0.111 and so on. And if you try to find out here the same value using the double star notation, you can simply replace hat with double star and still you will find the same operations you can see here. Now I try to take here one more example, say 2, 3, 4 and here 5, and I try to take it here, say cube. So now this is hat 3, so this is cube. So this cube operation is going to be operated on each of this element inside this data vector having values 2, 3, 4 and 5. So this will become here 2 cube, 3 cube, 4 cube, 5 cube, and you can see here the values. 2 cube is 8, 3 cube is 27, 4 cube is 64 and 5 cube is 125. And now in case if I try to do here the same operation with here with some negative power also, that will also work here, that you can see, right, there is no issue at all. And the same thing if I try to replace it with the double star operation, you can see here it is giving you the same value, right. Now I try to take an example where you are trying to work with the data vectors. So if I try to take here one example to C 2, 3, 4, 5, and suppose just for the sake of illustration I try to take here one more data vector of the same length. Suppose I can take it here 5, 4, 3 and here 2. So this will become here what? 2 raised to the power of 5, 3 raised to the power of here 4, 4 raised to the power of here 3, that is 4 cube and 5 square. So now if you enter, this will give you this value. 2 raised to the power of 5 is 2 into 2 is 4, 4 2 is 8, 8 2 is 16 and 16 2 is 32. Similarly 3 3 is 9, 9 3 is 27, 27 3 is 81. Then 4 into 4 into 4 is 64 and 5 square is 25. Now in case if I try to change this value, and if I try to remove the two values so that the second data vector has only two values, so what will happen here? This 3 and 2 will be operated on the first two values. So this will become 2 cube and 3 square, and then once again 3 and 2 will be operated in the remaining two values, and this will become here 4 cube and 5 square, and you can verify these values without any problem. And now in case if I try to show you here one operation, that if I try to make it here -3 and -2, what will happen? And instead of making here -3 and -2, if I make it here, what will happen? You can see here both are the same values. Yeah, that is correct. That because once you are trying to do here, for example, -3 and -2 as to the power on all these numbers, and here you are just trying to take this minus sign common, and inside the bracket there are only 3 and 2. But on the other hand, in case if you try to make here the second vector of the length, which is not the exact multiple of the first data vector's length, this will be here like this. 5, 4, 3, they will be operated over 2, 3, 4. So this will become 2 raised to the power of 5, 3 raised to the power of here 4 and 4 cube, and then 5 raised to the power of here 5, which is 3125. But there will be a warning message also. So that is how it is going to work. So now you can see here that these power operations in the R console, they are also not very difficult to operate, and they can be done without any problem. So now after this we try to take here one more operation, that is integer division. What is this integer division? For example, if you try to divide, well, I will use the primary class arithmetic. If you try to divide 2 by 2, this will become here 2 1s are 2 and remainder here is 0. And similarly, if you try to divide here 5 by 2, so I can write down here 2 2s are 4 and the remainder here will be here 1. And similarly, if I try to divide 7 by 3, so I can write down here 3 2s are 6 and the remainder here is 1. So that's how I was taught the arithmetic in my childhood. So that is the same thing. So now you can see here, when you are trying to divide any value with something, then you have here two answers. One is here and another here is remainder. So now when you are talking about the integer division, in this integer division, the fractional part, which is the remainder, this is discarded and only this value is going to be here. So similarly, if you try to see, this dividend here is 2 and here 2. So that is how we actually work in many programming. Sometimes you want to do such operations. So, and these are very common operations in mathematics. So in order to do the integer division, the command here is like this one, which is percentage sign on your keyboard, then this backslash and then percentage sign. So if you try to operate here like this here, 2 integer division, that is 2 percentage backslash percentage 2, then it is giving you the same value, and this value 1 is given here. And similarly, if you try to do here with 5 integer division by 2, like here this, so this will go here like this, and this value is given here. Right. And then similarly, if you try to divide here 7 by 3 using integer division like this, then this value here is given here like this, and this 2 value here is obtained here like this. So this is the concept of integer division in our software. And here you can see the screenshot of the same operation. So this is what you have to understand. And similarly, if you try to do this interdivision, when you try to choose one as a data vector and another as a scalar, the same thing will happen what has happened in the earlier operation, just like addition, subtraction, division, multiplication, that this operator, this will operate on each of this value 2, 3, 5 and 7. So this will be like as this 2 integer division by 2, 3 integer division by 2, 5 integer division by 2 and 7 integer division by 2. And you can see here 2 interdivision by 2 will give you answer 1 and 3 interdivision by 2 will also give you answer 1. 5 interdivision 2 will be like this, 2 2s are 4, so remainder here is 1, so this value comes over here at 2. And when you are trying to divide 7 by 2, 2 3s are 6, remainder here is 1. So this 3 will come here. So you can see here this is the same way as it was happening in other operation. The same process will be followed here also in the case of integer division. And yeah, in case if you try to take two data vectors, so if you try to take the data vectors of the same length, then each of the value in the respective position in the two data vectors will have the integer division operation. That is now very obvious for you. So just for the sake of example, I have taken here two data vectors. One is of length 4 having 4 values and another is of length 2 which has 2 values 2 and 3. So now this integer division will be operated over this set of values and then this set of values. So in case if you try to do here like this 2 integer division 2 and 3 interdivision 3, right? So this value will be say here 1 and 1. And now in case if you try to have integer division over this 5 and 7, so it will come here. So 5 integer division by 2 and 7 integer division by 3. So in both the cases the values are going to be 2, 2 2s are 4 and 3 2s are 6. So these two values are here and this is the screenshot of the same operation. Right. And similarly, if you try to take here a similar example where the first data vector has a length 3 and second data vector has a length 2, which is not the exact multiple of the length of the first data vector. So then the same thing will happen. These two values C2, 3 will be operating over the first two values in the data vector 2 and 3. So this will become here like this 2 integer division by 2, 3 interdivision by 3, and then this 2 3 will come here once again over the 5. So 5 will have the integer division by 2, but there is no other value with which something can be divided here using integer division. So this will give you here a warning message. You can see here this is the screenshot of the same operation. So let me try to show you these operations over the R console so that you get here more confidence. So you can see here if I try to say here 7 integer division 3, this will be here 2, and if you try to take it by 2, so then 2 3s are 6, the answer will come out to be a 3. And in case if you try to take here value here 5, 7, 8 and say here 4, and if you try to have the integer division by some scalar, so this you can see here like this. So this will be like here 2 2s are 4, 2 3s are 6 for 7, 2 4s are 8 and 2 2s are 4. So this is the value here. And similarly, if you try to use here some data vector also, so if I try to say here 2 3 3 and here 2 like this data vector, so what will happen? The corresponding positions in the data vector 1 will have the integer division with respect to respective positions of the data vector 2. So if you try to see here, this will be 5 integer division by 2, this is 2, 2 to the 4, 7 integer division by 3 which is here 2, 8 integer division by 3 which is 3 2s are 6, this 2, and 4 integer division by 2 which is here 2, 2 2s are 4. And similarly, if I try to make it here like this, say 4 and here 3, and if I try to remove the other two values such that the length of the second data vector is an exact multiple of the first data vector, this will be here 1 2 2 1. How? This 5 integer division by 4 1, 7 integer division by this 3, this is 3 2s are 6, and then 8 integer division by 4 which is 4 2s are 8, and 4 integer division by 3 which is here 3 1s are 3, this is 1. And in case if you try to say here 4 3 and 2 here, then you will get here like this 4 3, 2, they are going to be integer division for the 3 number 5, 7 and 8, and for the 4 there is only one value here 4, so it will give here 4 ones are 4, but for the remaining two values 3 and 2 there are no numbers here in this data vector where the integer division can be performed. So it will give you here a warning. So you can see here it is not a very difficult thing which you cannot do, and it is very easy to understand after learning all these topics. So after this I try to give you an idea about one more topic, which is the last topic of this lecture. This is about modulo division. Yeah, a popular name is like x mod y. This is how we call it. So what is this modulo division? If you remember, we have just done this exercise that I try to divide 2 by 2. So you will hear this will be here 2 ones are 2 and the remainder here is 0. And similarly, if you try to divide 3 by 2, this will be 2 ones are 2 and the remainder here is 1. And then similarly, if you try to divide 7 by 3, this will be here 3 2s are 6 and the remainder here will be 1. And similarly, if you try to divide 7 by say here 4, then will be 4 ones are 4 and the remainder here will be 3. So this modulo division, this gives us the remainder after division of one number by another. What does this mean? That when we are trying to divide 2 by 2, then the remainder is 0. When we are trying to divide 3 by 2, then the remainder is 1. And when we try to divide 7 by 3, then the remainder here is 1. And when we try to divide 7 by 4, then the remainder here is 3, integer values. And this modulo division will provide this remainder values. So for example, the symbol for operating the modulo division in our software is like this one, 2 signs of percentage like this. So if you try to have the 2 mod 2, which is the 2 modulo division by 2, then its answer is going to be here 0 from here. And similarly, in case if you try to have 3 mod 2, which is 3 modulo division by 2, which is here like this, and its remainder here is 1, which is the answer here. Then the next operation is 7 modulo division by 3, 7 mod 3, and this is here done here, and its remainder here is 1, which is here like this. And then the last one, 7 modulo division by 4, that is 7 mod 4, which is here done here, and its remainder here is 3, which is here like this 3. So this is the modulo division. It will give you the remainder. So now this I have illustrated when I am trying to take the scalars only. Now in case if you try to take the first data vector as like this C2357 and second value is the scalar. So now in this case, if you try to operate the modulo division, what will happen? Now this modulo division is going to be operated on each of this element 2, 3, 5 and 7, like this one 2, 3, 5 and 7. So obviously when you try to divide 2 by 2, then the remainder is going to be 0. When you try to divide 3 by 2, the remainder is going to be 1. When you try to divide 5 by 2, the remainder is going to be 1, and when you try to divide 7 by 2, the remainder is going to be 1. And this is here the screenshot. So you can see here this modulo division is working exactly on the same line as the other operations. Now in case if I try to take both the parts as data vectors, so the first data vector here is C2357 and the second data vector is C23. I can also take the second data vector of the same length, but now you know that how it is going to be operated. There is no issue in understanding. So now what will happen to this? That this C23 will come over here and this will be operated for the modulo division like this. That 2 will be operated over 2 and 3 will be operated over 3. And this will give you an answer 2 divided by 2, remainder is 0, 3 divided by 3, remainder is 0. Now once again this 2 and 3 will come over here and they will be operated over 5 and 7. So now this will be your here 5 modulo division 2, the remainder will be here 1, and then 7 modulo division 3 and the remainder will be here 1. So once again you will get here the values like this 0 0 1 1, and you can see here this is here the screenshot. So you can see here that in this case also the modulo division works exactly in the same way as other operations. Now I try to take the last example where I try to take the 2 data vectors for modulo division, but I try to take the first data vector which has got 3 elements and the second data vector which has got 2 elements. So the number of elements in the second data vector, this is not the exact multiple length of the first data vector. For example, if you try to see in this case, the length of the first data vector was 4 and the length of second data vector was 2. So the length of the second data vector was the exact multiple of the length of the first data vector. So now in this case, the similar operation will happen, that this C23 will come over here and it will try to operate over this C23. So this will become here 2 modulo division by 2 and 3 modulo division by 3, and after that one value is left. So this C23 will come here again and it will try to do this modulo division of 5 with respect to 2. So this will be here like this, but after that where to operate with this 3 in the first data vector, it is not given, it is not known to R. So it will not operate anything, but it will stop and it will give you here a warning message that the longer object length is not a multiple of shorter object length. So this is how this operation will be done. So this is here the screenshot of the same operation, and I try to show you these operations first on the R console, and then you will get more confidence. So if I try to say here 7 mod 3, so you can see here 3 2s are 6 and the remainder is here 1. Similarly, if you try to take here the first value here as say 7 and say 9, and then the second value is going to be here, suppose here 4. So you can see here now if you try to divide 7 by 4, the remainder is going to be 3, and if you divide 9 by 4, the remainder is going to be 1. Now if you try to take the second data vector also as a vector, and for that we try to increase the length of the first data vector, say here 7 9 3 4, and say other data vector I try to say here 2 3 and say here 2 and here 3. So you can see here now in this case this 2 and 3 they are going to be operated over this 7 and 9, and this 2 and 3 they are going to be operated over this 3 and 4, and you get here an answer 1 0 1 1. Similarly, if you try to change here the length of the data vector, and suppose if I try to take it here only 3 and 2, so what will happen here, that this 3 and 2 will be operated first over 7 and 9, and the 3 and 2 will be operated over 3 and 4. So if you try to see here, this modulo division will give you an answer 1 1 0 0. Why? Because if you try to divide 7 divided by 3, 3 2s are 6, remainder is 1, 9 divided by 2, 2 4s are 8, remainder is 1, 3 divided by 3, remainder is 0, 4 divided by 2, answer is 2, remainder is 0. So that is how the things are going to work. And if you try to take here the number of elements which are not exact multiple length, you can see here like this, that this 3 2 3 is going to be operated with 7 9 3. So 7 divided by 3, the remainder is 1, 9 divided by 2, remainder is 1, 3 divided by this 3, remainder is 0, and 4 divided by 3, this remainder here is 1. But it will give you warning message because there is no place where 2 and 3 can be operated over here, right? So that is the way we are going to operate on it. So now you can see here with this modulo division also you have learnt one more topic, that how these different types of power operation, integer division, modulo division, they are operated in the R software. So now as you can see now that as we are moving forward, more operations are coming and you need to remember more things. But my advice to you all is that whatever we are doing now today, please try to combine it with the earlier lectures also, and try to see how you can do better. There are some more aspects for these calculations which we have to learn, but after the lecture today, once again you have a good amount of homework to do. Please try to take these operations, try to take some values yourself, and try to do those calculations manually using your own hand, own pen, own paper, and try to verify it with the outcome of the R software. That will give you more confidence that the way R is thinking, you are also thinking. So now whatever you want to get it done through the R, you can write an appropriate syntax, command, function for those things. So you try to practice it, and I will see you in the next lecture. Till then, goodbye.